Good morning, Dr. Miller.
Morning.
It was a pleasure talking to you last time about the industrial management as well as the certifications this course offers for the students who want to do their masters. So in this video we are going to talk about the rapid prototyping and its uses.
Okay, great. Well, sure. I'd like to tell you all about it. What we have here is, rapid prototyping is what came out first because people had to make all these prototypes by hand, specialized equipment, and they really had to be skilled machinists to do this. Then over the years they were able to do what they call these rapid prototypes, where you will design, and you'll see in a minute, you'll design it as a 3D solid model using whatever, CAD platform that you prefer, and then you'll save it as an STL extension for stereolithography is what that stands for. And then that way, instead of having to machine this piece down and make it all by hand, this will automatically build it in layers, thousandths of an inch, and will build up pieces of plastic or even metal for the more expensive machines. And then you have your actual part that you're making done just like that, in a matter of hours. That's why they said it was for special prototypes, and that's why they called it rapid prototyping. Then you've seen it to where it's changed now, where they say it's additive manufacturing because it's built up, and you can look at it like we were saying in layers. So you're adding instead of subtracting, like you're machining something and making a prototype in that respect. So for instance, like we were showing these parts that we had made before, this was just drawn on the computer, and I have our students, they're able to make whatever they want, but they just drew a little quickly, like a big rig truck type deal, and for an 18-wheeler and that. And they quickly drew this, and we were using Autodesk Inventor at the time, but you can use Pro-E, Solid Edge, SolidWorks, whatever, or you can get something off the internet and then hopefully be able to change it a little bit depending on what you have, and then scale it down. Like this could be drawn at full scale, and then when you put it in here, which will show you it has a STL scale, you can change the scale to whatever size you want, a tenth, a hundredth, a thousandth of that, and so then it'll just make it all that much smaller. And here's one that we ran the other day. This one was of the FANUC robot that he had drawn on Pro-E, in fact, and that's just if you look at it, here's this robot right there, and then he could have made all the parts separate to where this actually would move and all that, and we could put little electric motors in there and make the whole thing run just at a smaller scale. Yeah, we imported, let's say, open an STL file, and you can convert it. Got different things here, but when it's usually an STL file, it'll make like this little certificate, and so we click it in, and it's made this FANUC robot. That's what it looks like. Now you look, well, here's our work envelope, was this little white rectangle, and obviously it doesn't fit in there, so we change the scale and put it down to 0.25, and see, now it fits in there, and then we're good to go. And then we can go the orientation. Well, if it builds that with this type of rapid prototyping machine, I don't know if you can see inside there, but it has this gray stuff. It has this support material, where what it is if it's making this plastic, if there's nothing to support it, then the plastic's just going to fall. And so you need some support material that breaks off. This is breakaway support material. Now they make a water-soluble type too, where you put it in this wash and it vibrates it, and it'll remove it that way, which is a little better. And that's what we do in this course. We have a computer integrated manufacturing course where we get into the robotics, we get into all of this 3D printing, rapid prototyping, all of that good stuff. We also get into the CNC equipment that manufacturing, so we have additive manufacturing. And then also, yes, we subtract it. So we do CNC machining, where we start out with a piece, whether it's aluminum, wood, or whatever, and then it machines away the area that we don't need. So.
Right, thank you, Dr. Miller. It was very nice talking to you about this topic.
Well, sure, thank you.
So much.
Appreciate you coming.